Welcome, and thank you for joining this webinar. From Connectivity to Understanding, the Semantic Future of AI Communications, prepared by the Alpert Research Team. Understanding semantic communication, or SEMCOM, is a strict strategic imperative. It literally represents the foundational shift required for the networks of the 2030s. Let's bring all of this deep science down to the bottom line, economics and business models. Because none of this happens if it isn't profitable. This is a profound hardware paradigm shift. Bit-centric 5G systems are bandwidth-bound. They need more spectrum. Semantic systems are compute-bound. They need more processing power. We are actively moving away from general-purpose CPUs and GPUs toward neural processing units, or NPUs, and highly customized ASICs built specifically for AI.
Which is a vital transition for the telecom industry. Carriers are in a crisis. They must reconcile exponentially rising data consumption with entirely stagnant telecom revenues. Customers want 100 times more data, but they refuse to pay $1 more on their monthly cell phone bill. Consequently, telco operational expenditure, or OPEX, is currently 4 to 5 times higher than their capital expenditure, or CAPEX. They are bleeding money just keeping the networks running.
But wait, if semantic communication reduces transmission overhead by 99%, how do carriers make money? If AT&T charges by the gigabyte and SEMCOM destroys the gigabyte, doesn't semantic communication completely destroy their revenue model?
It destroys their old revenue model. Strategically, they are shifting from pricing raw bandwidth to pay-per-insight models. They will no longer charge a factory for how much data they use. They will charge for guaranteed task success and highly specialized semantic-aware quality of service tiers. They monetize the intelligence, not the pipe. Furthermore, semantic communication drastically lowers the internal cost per bit by reducing the volume of data sent over massively expensive licensed spectrum. It also enables deep infrastructure sharing. The research highlights that 6G RAN slicing, where operators share the AI infrastructure dynamically, can reduce their CAPEX by up to 68%.
That is a massive financial incentive. And to make this work on the devices we carry in our pockets, hardware-software co-design is everything. Can't run a massive AI on a phone without melting the battery. But specialized NPUs offer 35 to 70% lower power consumption than traditional GPUs. They are perfectly optimized for the specific INTA quantization math that neural networks use. The sources show systems using what they call LMN.NPU offloading, which reduces large language model pre-fill latency by an astonishing 22.4 times. That incredible efficiency is literally the difference between a viable 6G handset that lasts all day and one that drains its battery in 15 minutes.
This transition is mapped out across 3 distinct deployment phases.
The first is the foundation phase, occurring roughly between 2026 and 2028. We are entering this phase now. This is the critical period where semantic communication transitions out of academic theory and into pre-commercial prototyping and standardization.
We are already seeing the physical proof of concept.
Using software-defined radio testbeds, they are actively proving that semantic encoding can drastically lower transmission energy and reduce latency for specific high-value tasks like robotic control and holographic telepresence. However, the primary goal of this foundation phase is for the standards bodies to agree upon a unified evaluation framework.
Because if the industry cannot agree on how to mathematically measure task success rate or age of information as replacements for bit error rate, nobody can write a procurement contract. You cannot buy, sell, or regulate equipment if you cannot objectively prove its performance.
Phase 2 is the scale phase, projected for 2028 to 2032. Assuming the evaluation metrics are standardized, this is when we expect to see mature semantic network slices and semantic RAN controllers deployed in live commercial environments.
But it won't be on our smartphones yet. The research suggests these early deployments will be hyper-focused on high-value enterprise use cases. We will see them in private 6G networks managing automated smart factories, coordinating massive drone logistics fleets, or managing closed-loop autonomous transit systems.
And finally, we reach the maturity phase, extending from 2032 to roughly 2035. As we approach 2035, the strategic vision predicts that the global cellular infrastructure will have completed its transition. Networks will shift entirely from entities that merely move data to entities that actively participate in the collective intelligence of society.
Which brings us perfectly to the strategic outlook. We are looking at the most significant wireless evolution since the leap from analog to digital. We're finally solving the looming spectrum crisis through intelligence rather than brute force. Leaders must prioritize 3 distinct pillars for 6G readiness. Number 1, unified theoretical frameworks. We must invest heavily in semantic information theory to ensure we can build standardizable, interoperable protocols. We have to move away from fragmented, proprietary black box neural networks that can't talk to each other. Number 2, AI native edge cloud integration. We have to master the compute connectivity continuum where local edge extraction meets tower level physical layer control. And number 3, hardware acceleration roadmaps. All product development must align with NPU energy efficiency and AI-native chipsets.
And as we noted, the immediate focus is engaging deeply with the 3GPP Release 20 and 21 standardization processes right now and investing heavily in the knowledge base infrastructure that will power this. So if you had to distill everything we've explored today, from Claude Shannon to AI hallucinations, into one core takeaway for the decision makers listening, what is it?
It is simply this. Prioritizing the transfer of meaning over the transmission of bits is the absolute cornerstone of the next era of global connectivity. It is the only mathematical and economic way we scale successfully into the 2030s.
It's an incredible technological shift to witness.
From Claude Shannon's rigid mathematics in the 1940s to the AI-native architectures rolling out in the next few years, the core takeaway is clear. Prioritizing the transfer of meaning over the transmission of bits is the absolute cornerstone of the next era of global connectivity.
It's the only way forward.
It is the only mathematical, physical, and economic way we can scale successfully into the 2030s. Interested in gaining a deeper understanding of the transformative power of wireless technology? Join the Alpert Research Team's webinars to explore cutting-edge wireless innovations, their applications, and their strategic implications. Click the links below to learn more. Thank you for taking this deep dive with us. Keep exploring and keep asking questions about the hidden architecture of our digital world.